Good. Good evening, everyone. So let's get started. I will show you two code bases. So there is one code base that is written by me. And let's, so in this code base, the code that I have written, I will show you how to traverse the parse tree generated by the parser, which is in turn being generated by the ANTLR4 parser generator tool. And using that parse tree traversal code that I'm going to show you, it will be very easy for you to construct an AST. And then I will show you a second code base which is written by Anish. That is, it contains a code to construct the AST for expression grammar, but that code is little bit unclean. So let's get started. This is the grammar that we have here. It is there in the file expr.g4. And so on line 4, we have the production which states that a program is one or more statements. A program consists of one or more statements. That plus stands for that. And start itself is a non-terminal symbol. And there are three substitution rules: expr new line, id equal to expr new line, or just new line. And you see that I have three annotations which are starting with pound symbol or hash symbol against each of these production rules, and there is a reason for it. And then on line from line 11 to line 16, you have various substitution rules associated with the non-terminal symbol expr. And again, associated with every substitution rule, there is a tag that is given. This tag is not part of the substitution rule, but this tag gives a name to that substitution rule. This turns out to be important when you are writing a visitor routines, any kind of visitor you want to write over the parse tree that is constructed. These tags become important. So now let's on line 18 to line 21. So it's a description of the tokens. You see, I have an example input for this here. If you see test input one.text. So in the first line, it's an expression, it's a statement. It's it contains only new line character. The second line is also a statement, and it is expression followed by new line character. The third line is also a statement, but here you have an assignment, that is id is equal to some expression followed by new line character. So these are three example inputs that we will be working with. Now let's go to main.cpp. So here you can see expr lexer.cpp, expr parser.cpp, expr build ast visitor.h. So line 7, this is what is written by me, and line 3, it's an ANTLR runtime.h file provided by the ANTLR parser generator. Lines 4 and 5, they are generated by the ANTLR parser. ANTLR4 tool generates those files. They are machine generated files or the tool generated files. And this is the main function. And in this main function, so line 13 and 14, so we are providing the program that we would like to parse as an argument. And we are opening that file and associating it with a stream. And yeah, line 16, we are declaring some ANTLR input stream by name input. So yeah, line 16, again, this is a boilerplate code. You can take this code base and just use it as it is. Line 18 is where we are calling this EXPR lexer. So this EXPR lexer, it's a class that is generated by the ANTLR tool. Similarly, on line 20, we have EXPR parser. This is again a class generated by the ANTLR tool. And on line 22, this is where the real action happens. So we are setting up, we are calling the parser, and we are asking the parser to parse the input starting with the non-terminal symbol prog. Okay, so this is starting from this prog. We are telling the parser to start parsing. And after the parsing happens, the root node of the parser, the root node of the parser of the parse tree, it will be returned, and we are storing it in this variable pointer to the root node uh, in CTX, in a variable called CTX. And then once we, this program, this PROG context, this PROG, it is, this prefix corresponds to the non-terminal symbol PROG. Remember, we are expanding the tree starting from PROG. So the AST root, the node associated, with the AST root, it is of this particular type. It is of this particular type. And then on line 24, we are, so we will see, we declared a visitor, we are creating a visitor object, build AST visitor object. And then on line 26, we are, we are making a pass, we are doing a traversal of the AST, not the AST, of the parse tree by using this by using the line that is there on line 26, by using the statement that is there on line 26. So there are a couple of questions. How are the two CPP files generated? So we will, I will show you the make file. They are generated automatically. Is prog fixed in convention? So prog is the first rule. So we remember, if you go see this one, so on line 4, prog is the start symbol. If instead of prog, if it is program, then you have to use program. So it depends on what is the starting non-terminal symbol in your grammar. Right? It can be anything. So on line 4, the non-terminal on the left side, it can be anything. So let's take a look at the main, at the make file. So you just use the ANTLR4 tool to, let me expand it a bit further. So you, yeah, so this is how the make file looks. And so on line 4, we are generating the parser. And on line 5, we are compiling the generated parser. And we are compiling main.cpp, and then the executable is generated, is written to a file named test. And then you have to include, yeah, so all these things, when you look at the make file, you will see. -l ANTLR4 runtime. So when I tried to compile it and try to run, I got some problem yesterday. Oh, I have an issue now to run this. I didn't set up the ANTLR4 runtime. C++ runtime on my machine. So I did all this work on my home desktop. Now I am in trouble. How many of you have set up C++ runtime on your machines? C plus ANTLR4 C++ runtime? I'm really sorry, guys. So let's do one thing. I need 10 minutes time to set up this ANTLR4 runtime on my machine. I completely forgot the fact that the whole thing is set up on my home desktop, and I just came to office to do this session, and this whole ANTLR thing is not set up on my machine. What I will do is I will sign off now, and I will get back, let's say, hopefully in 10-15 minutes, uh, or I'll just be here online, and if you, we can also do it, but I'll stop sharing my screen. So could you show us the process? Yeah, let's see. I didn't even set up the ANTLR also on my machine. Let's see then what happens. Hmm. So what do? I download ANTLR4. So you have to bear with me. I just missed this completely. So maybe I may need some 10 minutes to set this. Getting started. Okay. Okay, at least yeah, the basic ANTLR4 got installed. So now I have to install C++ runtime. So what did I do? So let me go here, git clone. So you know that if I log in, take this virtual class from or tutorial from home, there could be bandwidth issues and all that. So in the last minute, I decided I should come to office and do it. But I totally ignored the fact that this environment is not set up on my office machine. So, sure, Apurva. I will upload the previous lecture and today's tutorial also online. By end of today, I will do it. Great. So let's see what this says. ANTLR4. Yeah. Compiling on this. I have to go to CD ANTLR4, CD runtime, CD CPP. So those of you who didn't do this step, maybe you can try to do this now along with me. I hope I wouldn't get a problem today. Let me see. ls user local. Ah, no package. Sudo. Okay, let's see what apt install. I should do clean. Is there a CMake clean that we have to do? Let's try this. Awesome. Thank you, Rishabh. Great. And then there is a make. Is there any proxy settings I have to set up? Because it should come automatically, right? So any ideas on how to solve this problem? So do we need to set up any? Is there anything that I can do to make this work? This is thinking. Or should I manually git clone this and then try it out? Can this? It doesn't work because it will clone it somewhere. You may not get this problem because you may not be behind firewall or no proxy on your machines. No, it should work. I kind of clone from GitHub all the time, but huh? Why GitHub ping is not working? This should work. Well, there is a way to. Oh, is there a way to get through this? But it is part of the build process. Even if you download it in on line 8 in runtime, runtime CMake list, ANTLR4 runtime CMake list. Where is it, Rishabh? It's not there, no? There is one more suggestion. It could be a proxy thing. So that's my guess. So Ubuntu installation, cmake UID, mkdir cmake dot dot. Okay. So should I just try cmake dot dot? So let's see what happens. So where is that line? So where is that file, Rishabh? I'm not able to get it. Which directory is it in? It is here. This cmake lists dot text. Is this the one? Yeah, yeah. So GitHub, it's not the thing. No, I'm able to clone the ANTLR4 cloning. No? So it's not. So Rishabh, can you tell the directory in which you are saying line 8, which one I should see? CD build. So this is the place where we are in pwd, and then I said make. It's not working. Let's try this one, destination. ANTLR4 runtime, cpp, cd runtime, cmake lists, line 8. Yeah, so what should we do here on line 8? So here instead of git, we should keep HTTPS. Huh? Ah, okay. Yeah, it may work. Where is the build directory? So, yay, awesome. should have used parallel make to expedite this process. So now speaking of compilers, so this is where compilation time really matters when we are working on small toy programs with 100 lines of code, 200 lines of code. The compilation time doesn't really matter, and linking time also doesn't matter. But when we work on large projects, if you make one small change in this code base and when you try to do linking, compilation and linking, so this compilation time and linking requires a lot of effort. So why does linking require so much memory? I think it maintains lots of internal data structures to do some kind of to fill up the gaps in addresses of function calls, etc. Great. So now let's so Control Shift V, destination, user, local, lib. Yeah, let me make install. It is here, huh? Okay, I think I gave a bad path, but for the time being, I think we can destination directory. Yeah, just do sudo make install. If I simply do sudo make install, where will it be present? All the libraries. Huh. So the libraries are present in user local lib. Okay. All right, no problem. I think we are good now. So yeah, we are all set, I believe. So now let's go to the code base. expr AST. Yeah. All right, great. So successfully, the whole make process successfully went through. Nice. And the executable is present in .test, and then we have to present. Yeah. So this is the error you may get. So what you should do in order to fix this error is you go to bash rc and say export ld underscore library underscore path is equal to slash user. What is the place where it is present? Lib slash user local lib slash user local lib. Okay, now if I do a test input one.txt. Awesome. So the whole thing is running now. Thanks everyone for helping me out in getting to this stage. Let's get going now. So this is the make file. I'll share this make file. So pretty much you can use the same code base. But what I would like you to please pay attention to what I highlight here. So if you go to expr visitor.h, expr visitor.h, when you compile your code, you get this statements, you get this class that gets automatically generated, expr class. And then for every non-terminal, actually for every production, you will see a visit method. If you see associated with, let's go to the grammar, expr.g4, associated with prog, production rule, non-terminal symbol that is there on line 4, there is only one, let me bring, I'll close this one. Maybe I'll move this also here. This is important. Associated with this, you have only one visit method, visit prog. But then associated with the non-terminal symbol stat, there are 3 visit methods there. These 3 visit methods, one is visit stat expr, one is visit stat assign expr. Depending upon, this is visit stat expr, visit stat statement assign expr, visit statement new line. Associated with every tag that you provide, you have provided a tag with each of the substitution rules. For each of them, in the expr visitor.h, a visit method will be generated. Similarly, for expr non-terminal symbol, there are these 5 substitution rules, and associated with each of the 5 substitution rules, you see you have 5 different visit methods that are generated. This will be generated by the ANTLR4 parser. If you don't use these tags here, then what happens is there will be only one visit expr method gets generated. And when you hit a visit expr node, then you have to figure out what is the substitution rule that is being used by examining various fields at that particular AST, not AST node, at that parse tree node. That is a bit clumsy thing to do, and that's what Anish did. So the code written by Anish, so you go and when you are visiting a particular AST node, not AST node, parse tree node, it's when we are at that parse tree node, it is not clear which of the substitution rules are used to expand a parse tree node. So you have to examine various fields to figure out which one to use. So let's go to the code written by Anish. This is the code written by Anish. So if you see in his calc.g4, he didn't tag this is a slightly different grammar than the grammar that we have, that I have used. These substitution rules are not given any names. They are not tagged. So what happens is, so because of that, if you see his, for example, visitor postfix visitor.h, this is not the thing that we should be looking for. We should be looking for calc base visitor.h. So if you see, so he has written a visitor which derives that the class that is generated by the ANTLR4 parser. And if you see, there is a visit method. There is only one visit method, that is visit expr. And here, so he is trying to figure out which substitution rule is being used to expand this parse tree node. In order to check that, he is checking if no, if open parenthesis is there. If that is the case, do something. Otherwise, if yeah, try to figure out what is the other substitution rules that is being used, things like that. So I feel this is not the right way to design your AST construction. module. I will share this code also with you, but this is not the right way to do it. The right way to do it is, since we are all hacking, Anish first developed that version, and then I felt we have to find a fix for it, and I went and looked at the textbook, and then I got this hint, and so here we are. So you tag each of the substitution rules, and when we tag, then what happens is in the expr visitor.h file generated by the ANTLR4, you get for every tagged substitution rule a visit method. So when you compile your program, your expression grammar using ANTLR4 tool, this .h file automatically gets generated. And so now what we do is, so you write your visitor, your visitor could be evaluating the expression tree, or it could be constructing the abstract syntax tree, or whatever it is. But I suggest that you construct the abstract syntax tree and then do the rest of the things. It is a clean way to do it. So now if you see, yeah, let's see. Let's go to, so this is let's say this is the file. Let's say if I give this code base, this is the file you should be expanding. And the important class here is expr build AST visitor, which you will be defining. And it inherits or implements the abstract class expr visitor, which is generated by the ANTLR4 parser. So for every method that is generated here, you will have a method in this class also, and you have to implement it. You have to write code for it. Like for example, so there is this function, there is this method visit prog. Uh, it takes expr parser. It takes as parameter a node which is of type prog context. And for you, in order to understand how your whole expr parser looks like, you should go and look at that expr parser.h file. So if you go, yeah. So if you go look at this expr parser.h file and expr parser.cpp, more than this, you can just look at expr. You can see expr parser. This is the class, and then you can see there are multiple classes, like for every statement associated with every non-terminal symbol, there is a class. And so let's say if you're working with, if a node corresponds to a statement, then the object associated with that node will be instantiated using this particular class definition, right? So if you see this program context, so in this program context, I want you to pay attention to a couple of fields on line 41 and line 42. So line 41, it's a vector of statements, because program is a list of statements. So line 41, so if you look at the object associated with the prog non-terminal symbol, or the prog non-terminal symbol in the parser, if you want to iterate through all the statements, because a prog is a list of statements, then you want to use this field 41. So this is a vector. So whenever you want to understand how a particular parse tree node object looks like, you should go to the generated.h file and understand how it, what fields are available and how you can use them. Similarly, if you look at the statement context, so statement context, this is a bit tricky. So now you can see there is a statement context, and there are three different kinds of nodes that are defined. One is assign expr context. This corresponds to, this one. So if a parse tree node is expanded using this substitution rule, then the object that is generated at that particular place is comes from this class start assign expr context. This is not expr, yeah. So this is this is expr context, but then assign extra, there are, this is the one, assign start as expr context. But on the contrary, if it is a id is equal to some expression, then the corresponding parse tree node will be instantiated using this object. And you can see there are three fields. One is id, the other is expr, and the other is new line. So if you want to know what is the identifier that is being used, so then you have to use this field. You have to probe this field to know what is the identifier that is used, identifier token that is there in that particular parse tree node. And if you want to traverse the subtree associated with the expr, then you have to use the field on line 69. So what I am trying to tell you is when you when you compile your grammar using ANTLR4, if you want to understand how different parse tree nodes look like, then you should go look at this expr parser.h. And this is how I kind of figured out what fields are available and how we can use these fields in the AST construction. So this is one pointer. Next is, now let's come back to the visitor. So let's say you are visiting, how do you process your your parse tree node associated with the non-terminal symbol prog? So I just printed that we are in prog, that is what we are doing on line 13. And on line 15 to line 18, remember in the, if you go back here, so if you see here on line 41, it's a vector of statements. So what we are doing is, so we are iterating through this list of statements, and every statement we are visiting. This is what we are doing on line 17. And so we just call visit statement, and depending upon whether the statement is a start expr statement or assign start expr statement, what happens is, let's say if it is a plain start expr statement, this is what it is, this is what it is. Then how are we processing it? I'm just saying we are printing hey, we entered a parse tree node corresponding to statement expression, and then I would like to just visit the expr, so we just call a visit function. And let's say on the contrary, if this statement is a start assign expr, then automatically through dynamic dispatch mechanism, automatically the method on line 29 will be invoked. And what we are doing is, we know here the statement is id is equal to something. So I just printed here that the identifier here is this. And after we print the identifier, we would like to further parse, further traverse the subtree associated with expr. So we are doing a call on that visit. And if it's a visit start new line, if the statement is just new line, there is nothing to process. So we are not doing anything here. All right. So now if the, so let's say if the expression, so now here if you see on line 33, we are trying to visit an expression. An expression can be a plain integer expression, in which case this particular method will be invoked. This particular method on line 42 corresponds to the substitution rule on line 4, on line 13 here. Okay. And then all we are saying is, yeah, here we are visiting this expr int parse tree node, and the integer that is present is this, and we are printing that integer. And on the contrary, if we are visiting, if the particular node corresponds to this substitution rule that is there on line 12, then what we have to do is we visit the left tree and we visit the right tree, and then we do something about the current parse tree node. And we have to check here actually. And then here what it is doing here is we have to check whether it is addition or subtraction operation. I didn't check it. I just said, yeah, we are here. So visit left, visit right. And similarly, when we visit, if the EXPR is of type identifier, so you don't need to do anything because it's a terminal node. You just print the identifier. If it is a parenthesis, if the EXPR is parenthesis, expression under parenthesis, again, I didn't do anything. We just left it here, so on and so forth. So this is the whole point. This is how the whole code is structured. And if you want to construct an AST, it is very simple. Like for example, what you have to do is when you are visiting no, in this code, in the method associated with line 58, you have to create an AST node associated with identifier. And instead of returning null pointer, you return that AST node, right? Similarly, if you are visiting this expr int, instead of you create an AST node of type int and you return it instead of returning null point. And on line, and if you see, how do you construct an AST? So on line 50, if you see this method, you just have to check whether addition operation or subtraction operation is being used. And then, so whatever that line 53, the visit method from line 53 gives, you use it as the left child. And whatever from the line 54, the visit method from the line 54 gives, you use it as the right child, and then you construct an appropriate AST node and return it back. So there is a question. So we want to return AST node. So I think there is a Vibo. It's a good question. So, but I think this any type, this kind of does the trick. It should not be a problem. It should not be a problem, Vibo. So this is how you do the whole AST construction. You just take this base code and then you can make it expand this base code so that your whole of the grammar is taken care of. And so let me first finish the discussion here, and then maybe I'll take questions from you. So there are some issues, but this is the basic principle. So, and then after we construct this is how the whole visitor class is defined. You construct a visitor and then you invoke this visitor using the statement on line 26. And what you get is what you should get a pointer, a return pointer. You should get a return pointer. The whatever that is this line 26 it gives, it should be the root for the AST abstract syntax tree associated with the program. And when we ran the code, this is what is happening. As we are traversing the parse tree, I'm just printing which parse tree nodes are being visited, and if it's a leaf node like integer or identifier, I just printed them on the screen. So before I answer the question from Vaibhav, so at least are you all with me here? How many of you are with me here so far on this code example? So I will provide this code immediately now, and you can use it as the base. And so there is a, so I would say, so maybe constructing AST, it would be for your programming. So what you have to do is one thing that you have to remember is some AST nodes, you have the way you should think about your AST nodes is Your program is a list of methods. Like for example, if you think of your program is a list of methods. So the AST node associated with your program, it should have a field. One field should be a vector of method declarations or definitions. And then every method declaration, it's a list of statements or something like that. So think of, you should use the right data structures in order to appropriately capture the structure of your program. And if you see the Java file that I have posted on the course website, that Java file gives you some hints on how different nodes in the AST looks like. By and large, you should be fine. For example, if it's a binary expression, you know it has only two children. But the thing comes, your program, you know, your program is a list of methods. If you think of it that way, then you can immediately use some kind of a vector data structure that is available in C++. And if you think of your method as a sequence of list of statements, then you can immediately use an iterator, a vector data structure in C++, and use an iterator to iterate over the statements. So use the appropriate data structures in the design of your AST and check the Java file that is provided to get some hints. It is not complete, but most important ideas are covered in that Java file. Of course, you have to just map it to an equivalent structure in C++. And let's go to Anish's code again. So if you see Anish's code here, so I'm not sure, since I didn't finish the code to complete the AST construction, the problem which Vaibhav is pointing to on some casting error, I don't know what's the issue is. But if you see uh, this code from Anish, it works. I ran this code and it works. So here he is like, for example, this is a visit method for expr, and so on line 29 he is visiting the left subtree. On line 29 he is visiting the left subtree, and on line 30 he is visiting the right subtree. He is getting a pointer for the left expression tree, pointer for the right expression tree. On line 33 he is checking what is the operator that is associated with the current node. If it is a plus, he is creating a AST node with addition as the operator. If it is minus, he is creating a binary AST node with minus as the operator, and he is returning it back as by casting it to AST node star. Yeah, so and if it is a literal, if it's a terminal symbol, like for example on line 46, he is creating a integer literal AST node, and he extracted that integer literal by calling this function. So while I don't have an exactly, I don't know exactly what is the problem which Vaibhav is mentioning here, but I think if you use the code that that I have written, and if you see the code that is given by Anish, I think you can use both of these things together to come up with a plan to write a program no, which constructs the AST for the source program. And then, so once the AST is there, again use visitor design pattern to do semantic analysis and type checking. Does it sound good? Is the plan, is the broad plan all right? I'm just trying to see. So Vaibhav, I don't know, maybe if you can send in your error to Anish, maybe Anish might be able to, or post it on the Moodle, or no, send it to Anish. Anish might be able to help you.
Sir, am I audible?
Yes, Vaibhav, yeah.
Sir, actually, in Anish code, he is returning like AST node star, and
Mhm.
yes, this is correct. This will work. But let's say I have two subclasses of a. So I'll just explain the example from my code. I have a statement block, and the statement block can be either variable declarations or normal statements. So it contains variable declarations or statements. So I create a vector for statement block, and because the vector will be of statement nodes types. It should be able to handle both statements and variable declarations. So variable declaration and statements, these are kind of subclasses of AST node.
Okay.
So if I return those nodes and then try to cast them to AST node, that leads to the bad cast error.
You
Did you
cannot cast
understand?
them to AST node.
No, sir, that doesn't work.
So, but they are derived from AST node, right?
Yes, sir. Yes, sir. But because this antler returns this antler CPP any type, after the like we can't convert this any type into AST node after that. It doesn't work.
You cannot convert AST any type into AST node. Huh?
Yeah, given that that any type was actually a derived class of AST node. If that any type was a AST node, then the conversion works. But if the anything was actually a subclass of AST node, then it gives an error. And sir, this problem is there on 2-3 forums, and they have said that this exists, and they haven't really given a solution.
Mhm.
So
Let,
like we can't exploit the power of inheritance if that happens.
mhm.
So as a workaround, sir, I thought that maybe I shouldn't use what's the problem? Then what I'll do is I won't inherit calc visitor and just write all of the functions on my own. But now looking at your code, if I do that, then I won't be able to make use of the visit function. So I thought I'll create a class which doesn't returns ANTLR CPP any, but every time it just returns AST node, which was my super class. Then all the conversion and everything works. But then I won't be able to use the visit method which this calc visitor provides.
Okay. So you are saying since you say returning AST node star, so all the derived classes. So what is this any type? Is it a C++ type or is it defined?
It's defined, sir. It's defined in one of the files. I didn't understand what exactly it is, but it's defined in one of the derived. So not in these files, but in the ANTLR runtime, it's defined. I think ANTLR runtime.h.
Yesterday I was looking at this definition. Okay.
Sir, it's in USR local include. It won't be here.
Yesterday I was looking at it, but now I think it actually may work because once I opened it, peek. Oh, So how far are you able to progress? Like for example, it seems like for binary expressions it is working, right?
Sir,
So
for
where does it?
binary expression, it's only AST node. So
Sorry,
because that hierarchy is not there, it works.
if the hierarchy.
Sir, because in binary nodes, we are returning AST node directly and converting to AST node only. It's that is not an issue. But if we had a subclass of AST node and we returned that and then we converted it to AST node, that caused the error.
Mhm. So what if everything is a derived class of AST? Does it work?
Sir, I didn't understand exactly. So if AST is my parent and everything else is a children of AST,
Yeah, AST node.
and then I returned the, let's say, one of the children, child one, and then I tried converting it into AST node. No, sir, it won't work because that is the problem that base class once returned through this ANTLR CPP it cannot be converted to the parent class. It gives a bad cast error.
Once the base class is, it cannot be converted to the parent or the other way around.
No, no, sir. The first thing you said, like we won't need the other way around. We only need the base converted to the parent, base typecasted into the parent.
Mhm. Okay. All right, so I don't have an answer for this. I need to think about it. Uh, it's a good point, though, Vaibhav. I think it's something I'll ask Kanish and Jashwant to take a look at the problem um, and see if there are any workarounds for this.
Sir, it's hard to like proceed unless this is resolved.
Mhm. Okay. Okay, we will see. We'll try to work. So the all your buddies are also there. Let's see if all minds come together. If anyone has a solution for, first of all, you should come to a stage where you hit this problem. Okay. Um and so once you hit this problem, then we will see. At least I want to see write code and come to a stage and show at least hey, this is a problem. It's not like and then you will appreciate how they work around or whatever it is for it. Okay, so
So,
that's
sir,
what I would.
for
Sorry.
now, I'll just continue. So, for now, I'm not inheriting the calc visitor.
Mhm.
So, for now, I'm just creating my own visitor class, and I'm doing it the way Anish has done. Then, like, I haven't been able to generate a context for each and every separate rule.
Mhm.
So, I am doing it so this in this unclean way, but at least it's working.
Okay, okay, okay. All right, I think see, I would say you should work and see, just like as Vaibhav is doing. So you should try it, understand what problems you are facing, try to see what are the workarounds. So yeah, that's what I would say. So this is the help that we could extend from our side. I think you should also think and see how to solve these issues. Are there any hacks to do it, and what problems you are facing? Uh, you should explore and let us and tell, hey, this is this. I tried this much, and this is the problem I am getting. This much you should say, and then we will see after that what are the workarounds. See, these there are requests for deadline extension and all these things. I think it is unfair. So these homeworks are given before, and you didn't make any. I don't know how much. You should at least have come before 1 week before. I tried this, and the way Vaibhav is saying there's a problem here. So nothing like that is there, and then you say that we have assignments, we have midterm, and remember, see, the whole course is structured so that you will get, you'll work on the project, you learn, and instead of having an exam, so there's less focus on the exams. So you have to, uh, so from your side, you should also give in your best plan and try to give in, do your best. So I want to see what is the code that you can commit by this Saturday. What is the progress that is being made? Okay, there is no blind extension, and so as I told a week back itself, there is no deadline extension, and so with couple of hours effort, some kind of code base we are able to create. So I think you should put more effort and see how much progress you can make, uh, and then we will see. Okay, I think that's all. I'm not giving any deadline extension, so please work and tell me how much progress you made, uh, and what obstacles that you faced, and did you come up with any workarounds. So I want that there is no blind extension. It's not like everything is given to you, and so you can go around. So if you have workaround, Rohan, no problem. Please go. Yeah. So if you have any workaround, please go ahead and use the workaround. So I thought there is a nice, having a nice software architecture is good, but if there are any issues that we are not able to resolve, then it is all right. So you can use some workaround to solve that problem. Okay, so Saturday remains the deadline, and whatever the commits that you make, I will see and understand how much effort that you put in, what is the extent of your understanding. And so that's all for today then. So uh, see you tomorrow morning. Anything else you want to ask? Okay then. Bye and good night.